Okay, so can you hear me? Okay, so in this lesson, we are going to talk about another business intelligence theories. Okay, so Dr. YM10, and so in my first lecture, I have talked about the rule-based reasoning, and we also mentioned about the expert system, which is applied in the AI system. Okay. Now, in this lesson, we are going to go through another topics related to the artificial intelligence, which is called decision tree, as well as the neural network. Okay. Now, let me share my screen. Okay. So, okay. Okay, so in this lecture, we are going to talk about another very important theory applied in the artificial. Okay, okay, so which is called neural decision tree. Okay. Who is controlling my voice? Okay, someone mute my voice. Okay, please do not mute my voice. Okay. Okay. Go back to the lecture. Okay, so we are going to talk about the decision tree induction. Okay, so what is the decision tree? So decision tree is similar to the rule-based reasoning, which is a very commonly used artificial intelligence technique. So in this technique, we are going to make use of the decision tree to make some decisions. Okay, so why we call this is called decision tree, because in order to make the decision, we are going to make use of the binary tree structure. Okay, so for this binary tree structure, it consists of two parts. First of all, it's called root loop. Okay, root loop, that means we have a loop at the top. Okay, and then for this root loop, it will be divided into many different sub levels, which is called leaf loops. Okay, so that means this one is the root loops, and then it will divide into many different sub levels. So we have another leaf for this tree. Okay, so these are called leaf loops. Okay, so remember when we talking about the decision tree, so we are going to talk about the making decision for the binary cases. Okay, so what do we mean by binary cases? That means when we making decision, we only able to decide 0 or 1. Okay, that means binary. There are only two choices, 0 or 1, or yes or no decision, or true or false decision, or agree or disagree decision. So remember, when we're talking about the decision tree decision, we are going to talk about binary decision. Only 0 or 1, yes or no, true or false, agree or disagree, and so on. Okay, so remember, this is very important. Okay, so this is the basic decision tree method. Okay, of course, later on we have this develop many different decision tree algorithm, but in this lecture we just only focusing on the basic one, the standard decision tree algorithm. We will only making decision for the binary decision, 0 or 1, yes or no, true or false, agree, disagree, and so on. Okay. Okay, so in order to make this decision, we are going to divide them into different levels. So this is the top level. So for the top level, we start from the root, and then we have another sub level. These are the sub level, and then we are have many divided into many leaf loops, and then for each leaf loops, it will further divided into another sub levels with another loops and so on. Okay, so you will see that this one is just like a tree, okay, and then divided into many leaves. So that's why we call this algorithm is called decision tree. So actually for the decision tree algorithm, it can be applied in many different areas. For example, one of the major application is the loan proposal approval. That means when you want to borrow the money from the bank, okay, you need to the bank will need to make the decision whether they are going to borrow the money to you or not. Okay, they are going to making the decision approve or not approve. Okay, in this case, they are going to using the decision tree algorithm. Okay, this is real. Okay, so in the bank, this is actually how the bank to decide whether they approve to borrow the money to you or not. They are really applying the decision tree to decide whether they are going to borrow the money to the customer. So this is what they are actually doing in order to decide whether they are going to borrow the money to the customer. Okay, so one of the major applications is the loan proposal approval. So another application is like the medical diagnosis. Okay, so they would like to see whether the patient is really uh, have any kinds of illness or diseases or virus and so on. So in this case, they will also apply the decision tree. Okay, why? Because the decision tree can be applied in many situations. For example, they can use that for doing the classification based on the characteristic of the illness. So in order to perform the decision tree induction, there are many different algorithms. Okay, so one of the major algorithms is called ID3 algorithm. ID3 algorithm. So actually, there are many different algorithms to perform the decision tree induction. But in this lesson, we are going to using the ID3 algorithm. So this is the most commonly used algorithm for the decision tree induction. And so as mentioned, we are going to talk about the standard decision tree algorithm. So we are going to talk about the ID3 algorithm. So if you are interested, you can also search the other algorithm, but we're going to talk about this one first, okay? So in order to perform the decision, so one of the major important issue is that we need to have some historical data, okay? So as mentioned before, when we are going to making decision, we need to collect some big data. Right? Big data. So data is very important. Why we need some data? Because we need to, if you are going to apply the AI algorithm to learn the classification approach, we must need to have some information. So these information are the historical data. Okay, so remember when we apply the artificial intelligence, we need to have some historical data in order to apply the decision tree. Okay, so okay, so as mentioned before, in order to apply the decision tree, we can only able to classify them based on the binary decision. Okay, as mentioned, true or false, or accept or reject. Okay, so let's take a look on the most important example, bank loan approval example, because as just mentioned, the bank loan approval is what the bank is now applying in order to decide whether they are going to borrow the money to the customer. They really applying the decision tree in order to make the decision whether they are going to borrow the money to the customer. Okay, so as just mentioned, in order to decide whether to borrow the money to the customer, we are going to apply the decision tree. So as mentioned, for the decision tree, in order to come up with some decision, we need to have some historical data. So suppose that for this example, we already got some historical bank record. Okay, so in this record, we have already a list of customers. So the first column is talking about the name of the customer. For example, we have the customer Apple. We also have another customer Carson, Joe, John, and so on. Okay, so these are some of the historical bank record. So these are the name of the customer. And then for this customer, we have some attributes. We already have some attributes for the customer. For example, for each customer, we got the age, the status, education level, monthly salary, year of service, home status, year of residence, and so on. Okay, so these are the attributes of the customer. Okay, these are the attributes of the customer, and then we have list out all of these historical record. Okay, and then for this historical bank record, we have the final decision. Okay, for example, for the customer Apple, the bank decision is that the bank reject to borrow money to this customer. And then for the Carson, finally, the bank accept to borrow the money to Carson. So these are some of the historical bank record. We already know that, okay, this customer successfully borrowed the money, this customer failed to borrow the money from the bank, this customer failed to borrow the money from the bank, and these are the attributes of the customers. So this is the historical bank record. Okay, so in order to construct the decision tree, okay, as mentioned, we are going to apply the ID3 algorithm. So in this algorithm, okay, it is divided into several major steps. Okay, so first step is very important. Okay, you need to classify the instance into positive or negative instance. So what it means by positive or negative instance? So if the final decision of the bank is accepted, that means the bank accepted to borrow the money to that customer, then this is called positive instance. Okay, if the bank decision is rejected, this is called negative instance. Okay, so we have two major instances. Positive, that means accept. If negative, that means reject. So this is the final bank decision. Okay, we divide it into positive instance, accept, and negative instance, reject. Okay, so we go back to our historical bank record. So as mentioned before, there are 15 customers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we already got 15 historical bank record. Okay, and then as mentioned, you need to divide them into two different instances based on the bank decision, whether they are positive or negative. So we count how many positive instances. So for the positive, 1, 2, 3, 4, 5, 6. So that we have 6 positive instances. And then we count how many number of negative instances. That means reject for the bank decision. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9 negative instances. That means the band decision is rejected. And the total instance is 15. Okay, so this is the first step. Okay, we classify them into positive or negative instance, and then secondly, count the total number of positive and negative instance. Okay, we have 6 positive instance and 9 negative instance, and total number of instance is 15. Okay, so in order to apply the ID3 algorithm, we need to calculate. It's very important. What is the entropy? Okay, so we need to calculate what is the entropy for the first loop. As mentioned before, for the tree diagram, we start from the root loop. After root loop. Okay, so we need to calculate what is the entropy for this root loop. So in order to calculate the entropy, remember this equation. You need to apply this equation to calculate the entropy for the root loop. Okay, so what is the meaning of this equation? So in this equation, E representing the entropy, and what is X? X referring to the number of positive instance, and Y referring to the number of negative instance. Okay, so in order to calculate what is the first loop, the entropy, what is the entropy for the root loop? Okay, as we just calculated that we have 6 positive instance and 9 negative instance. Okay, that means we are going to calculate E bracket 6 and 9, because 6 referring to 6 positive instance and 9 negative instance. Okay, and then we substitute this value into this equation. Okay, X is equal to 6, X is equal to 6, Y is equals to 9, and so on. So this is very simple. Okay, we just substitute all these value X and Y into this equation. It's very, very simple. Okay. Okay, and then we need to calculate what is this value. What is the entropy? Okay, so do you know how to do the calculation? Okay, so in order to do the calculation, okay, you need to you can using the calculator, but when you using the calculator, for example, okay, let me use the calculator in the computer. Okay, now this is a computer calculator in the computers. Okay, you are going to calculate the value log. Okay, but for this equation, the base of this log is 2. Okay, but when we take a look on this calculator, the base for this log, remember, for base for this log is, do you know what is the base for this log value in this calculator? Okay, anyone can, maybe I don't tell you the answer first. Let me ask you, okay, do you know what is the base for this log value in the calculator? Okay, you may put down your answer here. Oh, someone is already answered the question. All right, yeah, 10, yes. Bingo, okay, you're correct. Okay, so remember, in the calculator, the base for this log value is 10. Okay, but in this equation, we are going to talk about the log value with the base is equals to 2. Okay, so that means, okay, 6 over 15, then we got 0.4. 6 over 15, we got 0.4. 9 over 15, we got 0.6, and so on. And then we are going to calculate this equation. Okay, so in the calculator, the base is 10, but in this equation, the base is 2. So what we can do, okay, we have a formula. Do you still remember this formula? Okay, log AB is equals to log B over log A. So very simple. Okay, so we have log 0.4 with the base is 0.2. That means it is just equals to log 0.4 over log 2. Okay, and then for this one is equal to log 0.6 over log 2. Okay, then we can using the calculator to calculate the answer. Okay, so 0.4 and log is equals to around negative 0.4. Okay, and divided by 0. Sorry, not 0. Divided by 2 log. So we got minus 1.322. Okay, so minus 1.322. Okay, and then we calculate what is the values for log 0.6 over log 2. Okay, 0.6 log over 2 log equals. Okay, so the value is minus 0.737. Minus 0.07. Okay, we got this one. Okay, and then we're using the calculator to calculate the answer. Minus 0.4 minus sine times 1.322 minus sine is equal to 0.529. Okay, usually in the calculation we will using 3 decimal place. Okay, 529. We don't need to use 5288. We just need to using 3 decimal place. 529 is enough. Okay, 0.6 times 0.737 and got 0.442 and then plus 0.529, and then finally we calculate the entropy with bracket 69 is equal to 0.971. Okay, so this is the first step. We calculate what is the entropy if there are 6 positive instant and negative instant. Now we have already calculated the entropy for the root loop. Okay, so entropy for the root loop is E bracket 69. Okay, so remember this is the entropy for the root loop. Okay. Okay, so this is the first method, method 1. We can using this equation. Okay, so another method. Okay, now let's do another method to calculate the log with the base equal to 2. Okay, so another method is to apply this formula. Okay, so when you're doing the assignment, doing the test question, so you can choose to using method 1 or method 2 in your calculation. Okay, so in this equation you see that a log b is equal to log to the log b to the power a. So that means, so this is a and this is b. Okay, so well, we combine them together. So finally we have 0.4 to the power minus 0.4. Okay, and this one minus 0.6, it will become 0.6 to the power minus 0.6. Okay, so remember, do you remember log a plus log b is equal to log bracket a times b. Okay, still remember the equation? Log a plus log b is equals to log bracket a times b. Okay, so that we got this one. Okay, log with the base 2 bracket this one times this one. Okay. Okay, and then we calculate the answer for this one. Okay, and then got this one. Okay, now we're using the calculator. Okay, for the 0.4 to the power minus 0.4 is equal to 1 over 0.4 to the power 0.4. Okay, and then times 1 over 0.6 to the power 0.6. Okay, so that this one is equal to this one. Okay, and then we're using the calculator to calculate the answer. Okay, 0.4 to the power 0.4. Okay, times 0.6 to the power 0.6. Okay, and then 1 over this one, 1 over this, 1 over this, then this one. Okay, so this is equal, this one is equal to 1.96. Okay, so this is 1.96, and then afterwards, okay, you need to apply this equation again. Okay, so not 1.96 with the power with the base equals 2, this is equal to log 1.96 over log 2, and then 1.96 log, and then divided by 2 log. Okay, so we got this one 0.971. So this value is the same as this one. Okay, you got the same answer. So this is the second method. You can using this equation. Okay, and then another method is the most easiest way is to using the Microsoft Excel. Okay, so let me using the Microsoft Excel to calculate the answer. So where is my Excel? Okay, let me open the Microsoft Excel. Okay, so for this Excel, it's very simple. Okay, let me enlarge this value. Okay, so you are going to calculate what is the values of not let me see. Okay, let me calculate this one, not 0.4 with the base equals to 2. So in the Microsoft Excel, so in order to calculate this one, okay, so this is the value. This value is equal to 0.4. And then this one is the base. 2 is the base. So we can use the Microsoft Excel. It's very simple. Okay. Now we want to calculate equals log, and then 0.4 with the base equals 2. And then we got the answer, minus 1.32 already. Minus 1.322, right? Okay. So another one, 0 log 0.6 with the base is equals 2. Okay. And equals log 0.6 with base equal to, which is equal minus 0.73 minus 0.737. So it's very simple. Okay. And then we can using the Microsoft Excel to calculate the answer for this one. Okay, so what is E bracket 69? Okay, the equation is very simple. Equals to minus 0.4 times this one minus 0.6 times this one. And then we got the answer 0.971 already. Okay, 0.971. Okay, remember using 3 decimal place is already enough. Okay, you don't need to write down 0.9709506. This is not necessary. Remember 3 decimal place 0.971. Okay. Okay, so there you can using these 3 different methods. Okay, using this equation or this equation or using Microsoft Excel, and then you got the same answer. 3 different methods. Okay, so after you calculate the entropy for the wood loop, okay, then you need to also need to calculate the entropy for the leaf loops. Okay, entropy for the leaf loops. Okay, and then what are the leaf loops? Okay, so actually, what are the leaf loops? Each possible attributes are called the leaf loops. Okay, so what are the possible attributes in the database? Go back to the database. This, as just mentioned before, okay, what are the attributes for the customer? So these are the name for the customer. It is not an attribute. It's just the name of the customer. And then this one is the final decision of the bank. Okay, so this is not the attribute of the customer. So what are the attributes for the customer? Age, status, education level, monthly salary, year of service, home status, year of residence. So these are the attributes for these customers. Okay, so when you're talking about the attributes, there are two different types of attributes. One is called continuous attributes. Another type is called categorized attributes. There are two different types. So what is the continuous attribute? Okay, let me ask you a question. Okay. So this one is continuous attribute or categorized attribute. Okay, this one, monthly salary, is continuous or categorized attribute. Okay, anyone can answer the question? Continuous. Okay, so any other answer? Continuous. Continuous. Okay, very good. Okay, so all of you got the correct answer. So this one, you will see that the monthly salary can be $1, $2, $3, $3.5, $6, and so on. So this is the continuous attribute. The age, you could be 27 years old, 28 years old, 29, 29.3, and so on. So age is also the continuous attribute. So year of service is also continuous attribute. So this is continuous. This is continuous. Year of service is continuous. Years of residence is also continuous attributes. Okay, so these are the continuous attributes. And for the rest of them, status, education level, home status are the categorized attributes. Okay. Categorized attributes. Okay. So go back to here. Okay. So we have the continuous and attributes. So after we have already calculated the entropy for the wood loops, we also need to calculate the entropy for the leaf loop. For example, as mentioned before, those possible attributes are the wood loop. Okay, so we start from the wood loop. Okay, this is a wood. Okay. Okay, and then it divides into many different leaf loops. So what are the leaf loop? For example, the age is the leaf loop. Okay, or salary is also the leaf loop, and so on. So we have many different leaf loops. So each possible attributes can be identified as the leaf loops. Okay. So after you know what is the continuous attribute, for example, we take the age as the example. Okay, we got the age. Okay, and then we for this age. Okay, we have the total instance is 15 as well because we have 15 data. Okay, and for this 15 data, as mentioned before, we got the root. We have the 6 positive instance and 9 negative instance. Okay, and then for this age, we need to further divide them into 2 different category. Okay, so as mentioned before, age is a kind of continuous attribute. So that in order to divide them into 2 different categories, we need to calculate what is the mean values, what is the mean age. Okay, what is the mean age? Okay, we go back here. Okay, we calculate the mean values for this age. Okay, 27 plus 35 plus 30 plus 25 plus 44, and then so on. Okay, and then divided by 15 is the mean age. Okay, by using this mean value, okay, we can further divide them into two different loops. Okay, the two different lift loop. Okay, lift loop 1 and lift loop 2 based on the mean age. Okay, as just calculate the mean age is equals to the mean is equals to 40. Okay, okay, and then if the mean age, if the age is less than 40, okay, we have the lift loop 1, and then for the lift loop 2, for those age larger than or equals to 40, and then we divide it into two different loops. One is less than 40 years old, another one is larger or equals to 40 years old. Okay, so you may think that, okay, can we divide them not based on the mean value? For example, can we divide them into 38? The answer is yes. You can using 38, or you can using 36, or 42. Okay, but the most common way is to using the mean value. Okay, so when you're doing the assignment, or if you are doing the test question, or doing the examination, if not specified, then you just need to calculate the mean value. So if it is already specified and tell that you need to using 36 to divide them into two groups, then you must need to using the 36. Okay, but in the ID3 algorithm, usually we will using the mean value unless it is specified. Okay, so based on this 40 years old, and then we will divide them into two different groups, two different lift loop. Lift loop 1 smaller than 40, lift loop 2 larger or equals to 40. Okay, and then after we have divided into two different groups, okay, then we calculate what are the number of the instant for those with less than 40 years old. Okay, the number of instance for smaller than 40 years old. Okay, okay, we go back. How many got less than 40 years old? Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay, we have 10 customers is less than 40 years old. Okay, and then we got 5 customers larger or equals to 40 years old. Okay, and then for these 10 customers, how many of them are positive instance and how many of them are negative instance? And then we go back to count how many of them are positive instance. Okay, okay, so this customer less than 40 years old, and then this one is reject. That means this one is negative instant, and then this one accept. This one is positive instant, and this one less than 40 years old, and this one is reject. This is negative instant. So this is negative, this is positive, negative, negative, positive, negative, and so on. Okay, and then you need to calculate for those customer less than 40 years old, there are 10 customers. And then for these 10 customers, 3 of them are positive instance and 7 of them are negative instance. Okay, and then there are 5 customers larger or equal to 40 years old, and then 3 of them are positive incidents, and 2 of them are negative incidents. Okay. Okay, so maybe we can take a break first to see if you have any questions. Okay, maybe we back at 7:20. Okay, 7:20. Okay, if you have any questions, please leave me a message here. Okay, so we take a break first and let me know if you have any question, and then we back at 7:20. Okay.
没有上网，下课中途休息。输一下我这个号码，他退钱给我。
哪里退钱？
之前交的那个课外活动课。100了。
100呀？
嗯。
是你学校的吗？
对啊。
妈的，学校才退100块钱。
我交了100嘛，他就退100了。
就是不能在校里面动啊。
嗯。
到时你回学校嘞？
到时候回学校，他都已经取消了啦。他都取消了，这就没得上的啦。
这课啊？
嗯。
这个是课程来的吗？
对啊。我那时候就交了100。
健身课是什么？
嗯，不是健身课，是一个关于财务的，然后还有一个是西班牙语的。
嗯。你这个是什么？
锡纸的。
吸油的。
嗯。吸油的。
你买这些明信片啊？
对啊。
是这些吗？
不是这些，这些不是吗？
这些可能。
对。那也不是，这个备注啊，这样子应该就可以。哎，为什么他说我不行呢？94392722，不就是这个吗？难道我不能用我的这个香港身份证吗？我一定要用我的护照。
护照是哪个？
可以哇，我真是醉了。
这个护照就行啊。
对啊。
就可以了。
嗯，他是用我的护照来帮我弄的，原来。
很棒啊！
对。
那你看它这里都印了这个11什么的。
对，这里都印了6249027。
哇，怎么打的这个洞啊？一直打不是我那个洞。这个可以。
对，它就会退钱，退到我这个卡上面去了。
天呐，全部印了。
对啊，很神奇吧？没想到我看得懂。
藏不处。
你看他要交学费呢，还要。
什么时候讲？
哎，这什么鬼啊？这个1月31号。哦，这个不用交。这个是14000的。哎，干嘛？喂，丁月，怎么了？
好想领你开麦。
干嘛？
你把麦关掉好吗？
哦。
Okay, okay, we start again. Okay, so we have already we have already divided the customers into two different groups. Okay, based on 40. Okay, so this is specified by using 40 to divide them into two groups. Okay, but usually we calculate the mean value. Okay, unless specified. Okay, so in this case we just using 40 to divide them into two groups. Okay, so originally we have 15 customers, and then for those less than 40 years old, we got 10 customers. For those larger or equals to 40 years ago, we got 5 customers. Okay, and then we count how many numbers of positive instance for this 3 customer. For this, how many number of positive instances for this 10 customer? Okay, we got 3 positive instance and 7 negative instance for those next than 40 years old. Okay, and then for the customer larger or equal to 40 years old, we got 3 positive instance and 2 negative instance. And then after we calculate the entropy for the wood loop, we also need to calculate what are the entropy for the leaf loop. Okay, in this case we got 2 leaf loop. Okay, leaf loop 1 less than 40 years old, leaf loop 2 larger or equal to 40 years old. Okay, we got 2 different group. Okay. Okay, and as mentioned before, besides we got the continuous attributes, we also got another type of attributes. We have to categorize attributes. Okay, for example, the education level is a kind of categorized attributes. Okay, so for the education level, we got tertiary education, secondary education, and primary education. Okay, so in this case, you need to list out all of these 3 different categories. Okay, for the education levels. Okay, so that for the education level, we got the leaf loop 1, leaf loop 2, as well as leaf loop 3. Okay, and then we need to count how many number of customer is got the tertiary education level. How many number of the customer got the secondary education level, and how many of them are primary education level? Okay, and then we go back to our historical data. We find that 1, 2, 3, 4, 5. 5 of them are tertiary education level. Okay, and then based on these 5 tertiary education level, we need to count how many number of them are positive instant and how many of them are negative instant. Okay, so this is positive instant, this is positive instant, and this is positive instant. So that in these 5 tertiary education level customer, 3 of them are positive instant and 2 of them are negative instant. Therefore, go back here. Okay, for the tertiary education level, we have 5 customers. 3 of them are positive instant and 2 of them are negative instant. Okay. Similarly, for the secondary education level, we have 5 customers. 3 of them are positive instant and 2 of them are negative instance. And finally, for the primary education level, there are 5 customers, and 0 of them are positive instant and 5 of them are negative instant. Okay, so this is the example of the categorized attributes. Okay, now we need to calculate what are the leaf loop entropy. Okay, leaf loop entropy. Okay, at the beginning we already calculate what is the wood loop entropy, which is equal to 0.971. Okay, and then for the wood loop we got 2 leaf loop. Leaf loop 1, and leaf loop 2. And then for these 2 leaf loop, okay, we also need to calculate what is the entropy for the leaf loop 1 and what is the entropy for the leaf loop 2. Okay, so for the entropy of leaf loop 1, E is the entropy. For the leaf loop 1, we classify that is less than 40. Okay, that means we are going to calculate what is the entropy E bracket less than 40. And then for the leaf loop 2, we need to calculate the entropy for them with larger or equals to 40 years old. Okay, that means we also need to calculate the entropy for the customer larger or equals to 40 years old. Okay, so in order to calculate the entropy less than 40 years old, okay, we take a look on this one. Okay, 3 of them are positive instant and 7 of them are negative instant. That means we calculate the entropy for less than 40 years old. That means we are going to calculate E bracket 37. Okay, as mentioned before, this is x. X is the positive instant, and y is the negative instant. That means if we are going to calculate the entropy less than 40 years old, we are going to calculate E bracket 3 and 7. Okay, so E bracket 3 and 7. So we go back to our previous slides. Okay, we need to use this equation. Okay, so this equation is very important. E bracket 3 and 7. So x is 3, y is 7. Okay, and then we substitute x is 0, 3 into this equation, y is 0, 7 into this equation. Okay, and then we apply this method and then calculate the answer. Okay, finally, we got E smaller than 40 is equals to 0.881. 0.881. Okay, so that means for the leaf loop entropy, E smaller than 40 is equal to 0.881. Okay, and afterwards we also need to calculate the entropy larger than 40. Okay, we are going to calculate what is the entropy for the customer larger than 40 years old. Larger than 40 years old. Okay, which is equals to E brackets. Okay, now we got 3 positive instant, 2 negative instant. That means we calculate E bracket 3, 2 and close bracket, which is equals to, so this one is x. Okay, this one is x, this one is y. Okay, okay, and okay, maybe I would like to give you 3 minutes to calculate the answer for this one. Okay, E bracket 3, 2. Okay, by using this equation. Okay, now I'd like to give you 3 minutes to calculate what is the result for the entropy larger or equal to 40. Okay, give you 3 minutes. Okay, please let me know the answer after you finish. Okay, very good. Okay, all of you got the same answer. Okay, so for the entropy larger or equal to 40 is 0.971. Okay, so wow. After you calculate, so as mentioned before, the wood entropy, the value is equal to 0.971. Okay, this is the wood entropy. This is the wood entropy. And then these are the leaf entropy. Okay, these are the leaf. Oh. Entropy smaller than 40 or larger than 20, larger or equal to 40. So for the smaller than 40, 0.881. For larger than 40, 0.71. Okay. Similarly, we also need to calculate the, well, you still remember, we got a lot of entropy, a lot of attributes. We got the age, status, education level, salary, year of service, home status, year of residence. Okay. After you calculate the age, you also need to calculate the other attributes as well. Okay. Status, education level, salary, year of service, ownership, year of residence, okay, and so on. So you need to calculate all of the entropies for all different attributes. Okay, you have to calculate all of them. Okay, wow, we don't have much time, okay, to calculate them one by one. So that means we just need to show you, we're going to show you the answer. Okay, so for example, for the single one, okay, we find that we have 7 of them are single and 8 of them are married. For 7 of them are single, 3 of them are positive and 4 of them are negative. For the married one, 3 of them are positive and 5 of them are negative. And so on. So you need to calculate all the entropy of all attributes. Okay, remember, calculate the entropy of all attributes. Okay, so after you calculate the entropy, so what is the use of this entropy? Is to using this entropy to calculate the information gain. Okay, so this one is very important. We want to calculate what is the information gain. So in order to calculate the information gain, okay, we need to apply this equation. Okay, so in this equation now, in this equation you see that, okay, the information gain, okay, for that attribute is equals to the entropy for the wood loop. So this one is the entropy for the wood loop. Okay, minus summation of, okay, let's see what are the leaf loop. Okay, for example, if you're talking about the age, if you are talking about age, you divide them into 2 groups. One is smaller than 40. So this one is smaller than 40. And then for this one is larger or equals to 40. Okay, you divide them into 2 groups. Okay, and then for, okay, this one for smaller than 40, this one is larger than 40. Okay, so if you are talking about the education level, then you need to divide them into 3 groups. Okay, therefore you have 3 summation. Okay, if you are talking about the education level, but when you take a look on the age as an example, we only have 2 groups. One is less than 40, another one is larger than 40. Okay, now we want to calculate what is the information gain for the age. What is the information gain for the age? So first of all, we need to using the wood entropy, the entropy for the wood loop. Okay, what is the entropy for the wood loop? We start at the beginning. The entropy for the wood loop is equal to 0.971. Or you can refer to this table. Okay, so the wood loop, the entropy for the wood loop is 0.971. Okay, so that this one entropy for the wood loop is 0.971, and then minus bracket. Okay, so what is the bracket? Okay, so this one is smaller than 40. This one is smaller than 40. Okay, so this one is equals to what is a loop instant? Okay, how many of them are smaller than 40? Okay, go back to here. We have 10 of them are more than 40, and 5 of them are larger or equal to 40. Okay, so that this one, 10 of them are smaller than 40, divided by total number of instances. Total we have 15 customers. Okay, and then times this is the entropy for the age less than 40 years old. Okay, this one is E bracket less than 40. Okay, so we just calculate E bracket less than 40 is equal to 0.881. This is 0.881, and then plus how many of them got larger than 40 years old? Let's just calculate. We have 5 customers larger than 40 years old, and the total number of customers is 15. Okay, and then times this one. This one is the entropy for larger or equals to 40 years old. Okay, so entropy for larger or equal to 40 years old. Still unvisible. So this one is entropy larger or equal to 40 years old. Okay. Okay, and finally, we calculate the information gain. We just actually, this is very simple. You just need to substitute all the values into this equation, and then you can finally get the answer. For the information gain of the age attribute is 0.0598. Okay. Similarly, you need to calculate the information gain for all attributes using this equation. Okay. Okay. Finally, you got this table. Okay, so this is the final answer. Okay, for the information gain of the age is 0.0898. For the information gain for the status is 0.0021. For the information gain of the education level is 0.3237, and so on. Okay. Finally, well, we've got the information gain for all these 7 attributes. We have 7 attributes. Okay. And then finally, let's look on this information gain. Now you find that for the information gain for the home status, the information gain, the values for the information gain is the largest. Okay, that means this is the best way to differentiate the sample data. Okay, the home status is the best attribute to divide the data into different groups. Okay, so that, wow. So in order to classify the customer into different group, we need to start from the one with the largest information gain. So as mentioned before, so the home status is the wood loop. Okay, the home status is the wood loop. At the beginning, there are 15 customers, and 6 of them are positive instance and 9 of them are negative instance. And then for the home status, it is divided into owned, mortgage, or rent. That means this customer own the flats, and how many of them are own the flats? We go back to here. Okay, so based on this historical data, 1, 2, 3. 3 of them own the flats. Okay, and then 1, 2, 3, 4, 5. 5 of them rent the flat, buy the flat but need mortgage. And 1, 2, 3, 4, 5, 6, 7 7 of them went to Fed. That means, okay, this one got the largest information gain. Okay, this is used as the root loop. Okay, and then 3 of them own the Fed, 5 of them do the mortgage, and 7 of them went the Fed. Okay, and then for this 3 customer, you find that all of them are positive instant. That means in this 3 customer, all of them, the bank accept to borrow the money to this 3 customer. And then for all of these 7 customer, all of them are reject to borrow the money to this 7 customer. It's very interesting. After you find out the whole status as the root loop, okay, and you find that for this leaf loop, okay, for those 3 customers own the flat, the bank will accept their offer. And then for those when the flat, 7 of them rent the flat, the bank will reject their offer based on the historical data. Okay, it's very clear. It's already divided into 2 groups already. And then how about those do the mortgage? And then you find that 5 of the customer do the mortgage, and then 3 of them are positive instant and 2 of them are negative instance. Okay, that means you need to go further another level. Okay, so we got the root loop divided into 3 different leaf loop. Leaf loop 1, leaf loop 2, and leaf loop 3. And leaf loop 1, we find that all of them accept the offer. And this one, we have 5 customers, and 3 of them are positive, and 2 of them are negative. And then for the leaf loop 3, all of 7 customers are reject. That means for this one, we need to further divide them into another leaf. Okay, that means this one need to further divide into further sublevel. Okay, now in order to divide into further sublevel, we need to repeat step 2 to step 3 for the remaining loops. Okay, we don't need to using the home status anymore. Okay, we need to calculate the other attributes. Okay, so in the second level, we need to do the calculation again. Okay, but now, okay, we change the total instant to only 5, and positive instant is 3, and negative instant is 2. Okay, we change to only 5 instant only. Okay, in order to calculate. So first of all, we start from the root loop. Okay, we want to calculate what is the entropy for this root loop. Okay, for this root loop, okay, we got 5 customers, and 3 of them are positive and 2 of them are negative. Therefore, we are going to calculating the root loop E bracket 3 and 2. Now 3 becomes X and 2 is equal to Y. Okay, and then we substitute X is equal to 3 and 2 is equal to Y into the equation to calculate the entropy. Okay, remember this equation. We substitute X is equal to 3 and Y is equal to 2, and then we calculate the entropy again, which is 0.971. Okay, and then similarly, so for the monthly salary, this one is the continuous attributes. For the continuous attribute, we can calculate the mean value, or in this example, we just using the salary less than $20,000 to cut in order to divide them into 2 groups. Okay, so for the customer less than $20,000, okay, we have 2 customers, and then 3 customers got the salary of larger or equal to $20,000. Okay, we divide them into two groups. Okay, and so this is the wood entropy. We just calculate the wood entropy. Okay, and then we also need to calculate the leaf entropy, larger or equal to $20,000, and entropy for the salary less than $20,000. Okay, so we calculate the entropy for the monthly salary larger or equal to $20,000. Okay, we got 3 positive entropy, false 3 positive instant and 0 negative instant, and we calculate the result is 0. And then for this one, for the entropy of monthly salary is less than 20,000 Hong Kong dollars, and X is 0, 0, Y is 0, 2, and then finally the entropy is equal to 0. Okay, and after we calculate the entropy, we also need to calculate the information gain. Okay, by using this equation. Okay, so this one is the entropy for the wood loop. That means this one. We have 5 customers, 3 of them got the salary larger or equal to 20,000. And for this one, salary larger than $20,000, the entropy is equal to 0. And 2 of them got the salary less than $20,000, and the entropy is equal to 0. Okay, and then finally we got the information gain is equal to 0.971. Okay. Similar to the previous example, okay, first of all, we need to calculate the entropy for all attributes: age, status, education level, salary, year of service, year of residence. Okay, after we calculate all these attributes, we also need to calculate the information gain of all these attributes. And then finally, we find that this one, the monthly salary got the highest information gain, which is equal to 0.971. Okay. Okay. Based on this entropy, we can further, okay, move back to previous slide. Okay, you already got this home status divided into 3 different leaf loop. Okay, we have the home status as the root. Okay, and then for this wood loop, we divide it into 3 different groups. One is owned, mortgage, or rent. For the customer own the flat, all of them will accept by the bank. For those customer rent the flat, the bank will reject their application. And then for the customer do the mortgage, okay, there are 5 customers do the mortgage. We cannot make the decision yet. Then we need to use another leaf loop, another level. Okay, we find that, okay, monthly salary got the highest information gain. And then for this monthly salary, we can further divide them into 2 groups. One is larger than $20,000. Another group is smaller than $20,000. And then for the customer larger than $20,000, we have 3 customers. And then for these 3 customers, the application will be accepted by the bank. And then for the customer, we have 2 customers with salary less than $20,000. All of them will be rejected by the bank. Okay, so we already got the answer already. Okay, so that finally, okay, after you got this decision tree, okay, so you will already got the answer, okay? And the answer is that if the home status is mortgage and the salary is larger or equal to $20,000, then the bank will accept the offer. Okay. So do you still remember this sentence? This is the rule-based reasoning. So that means after we apply the decision tree, we can making use of this decision tree, and then we can set up the rule-based reasoning. If the home status is mortgage and the salary is larger than $20,000, then the bank can accept the offer. So this is the rule-based reasoning. And then by using this rule-based reasoning, then we can set up the formula for the expert system. As mentioned in the last lesson, we are in the AI in order to decide whether we accept or reject the offer. We can make use of the expert system. In the expert system, we are going to using the rule-based reasoning. So in order to set up this rule-based reasoning, okay, we can using this decision tree to set up this rule-based reasoning. Then we can decide whether you accept the offer or reject the offers. Okay, so this is very important. Okay, we set up this rule for the expert system. Okay, another thing is that you can also further divide them into different risk level. Okay, based on the degree of the risk. Okay, so this is the risk level number 1. That means it has the lowest risk to borrow the money to these customers. And then this is the risk level 2. Okay, that means the risk level is fairly low. That means that it is very low to borrow to the money to those do the mortgage, and the salary is larger than $20,000. Okay, if the salary is less than $20,000, this is risk level 3. It's quite high risk. If you borrow the money to those rent the flats, we call this one risk level number 4. This one has the highest degree of risk to borrow the money to this customer. Okay, so by using this rule-based reasoning, finally we can set up the rule for the expert system, or we can set up the risk level to decide whether we borrow the money to these different customers. Okay, so finally, there are some strengths and weakness for this rule-based reason for this decision tree. The strength is that it is very simple, and this is very reasonably good method to making the decision support. Okay, we can able to generate the understandable rules path. Okay, it can able to load both continuous and categorize attributes. The weakness is that, okay, so remember that's the weakness is that, first of all, remember that we only able to decide the binary attributes, true or false, 0 or 1. Remember, the output is only a binary output. The output is binary, true or false, 0 or 1, agree, disagree, accept or reject, and so on. So these are the binary decisions. So this is one of the weakness. And other weakness is that, okay, in this example, we need to make use of this 15 historical bank record with 15 data, okay, to set up the rules for the express system. However, if we got more data, for example, later on we got 100 data, okay, if you want to set the rules, then you need to rerun the rule decision tree again. Okay, so this is very undiscernible. Okay, that means originally we got 15 data and then we set up the rules. But if we got more and more data, for example, we've got 100 data, then you need to rerun the decision tree again in order to get the new formula for the expert system. So this is another weakness for this rule-based system. So this is one of the constraints that is that we need to construct new tree if the additional instance is added into the training set. That means if we have additional data, then we need to rerun the decision tree again, and then we construct a new tree. Okay. So this is the end for the decision tree. Now maybe we can take a break. Okay, we can take a break, 15 minutes break, and then we'll back at a 7:45. Okay, a quarter to right break until 9:45, a quarter to 8. Okay, so if you have any question, please let me know. Okay. Okay, we back. Okay, so I'm not sure whether this topic is very difficult to you, but actually you find that you may need to have to do some calculation. But actually, when we're talking about the business intelligence, that means we nowadays we are talking about the artificial intelligence. So when we're talking about AI, you know that when we're talking about AI, we need to using the neural network. In AI, the, the concept and the algorithm using in the AI is using the neural network and also the rule-based reasoning and as well as the decision tree. So these are the fundamental algorithm and knowledge applied in the AI. So that when you talk about the AI, you are not simply applying the AI algorithm. You need to know what is the fundamental theory behind the AI because you are studying the master level. Okay, you are not talking about the bachelor degree. You are talking about the master level. So that if you are going to apply the AI, you must need to know some of the basic fundamental algorithm behind the AI. That's why we are going to talk about some topics like the decision tree, the rule-based reasoning. And then later on, I'll talking about the last one. Okay, neural network. Okay, this is very important in the big data, the AI nowadays. Okay, so before we go to the neural network topics, okay, first of all, I'd like to remind you that you need to form a group to do a project. Actually, you have already formed the group already. Okay, so if you go to visit the blackboard, okay, and then select your subject ISE5606, okay, and then on the left hand side there is a group, okay, and then I have already divided you into 17 groups already, okay. Based on your preference, if you haven't formed a group on your own, then I will randomly assign you into a group, and then you can click into your group, and then you will see the name of your group, and then you can using the blackboard to communicate to each other in order to do the lab project. So remember that. So this group, as mentioned before, you are going to do the lab project. Okay, my project as well as Dr. Jackie Ding project will also share the same group members, okay, to do the lab project. Okay, so what you are going to do for the lab project? So remember the teaching timetable. So the week during the March is not confirmed yet. We have to be confirmed because we are still waiting for the final decision from the university. So the timetable during the March is still to be confirmed, remember, okay? But remember that you need to do a group project, do the group project presentation. So this is the initial scheduled date, but I'm not sure because we need to wait for the university to confirm the final day, okay? So what you are going to do for the group project, okay? Actually, you can go to the blackboard, okay? And blackboard. So I have already posted the group project questions on the blackboard. So you can download the questions. Okay, so these are the questions for the group project. Okay, and so what you are going to do for the group project. Okay, actually you need to propose and do a presentation for a mini project related to the following topics: data mining application on customer valuation, data preparation for data mining in commercial application, security, or any other topics like test mining, video mining, web mining, and so on. So that you have to propose an application that can apply the data mining approach as well as the business intelligence approach. Okay, you can discuss with your team members and then finally come up with your topics. Okay, it is not limited to these topics. You can think about another topics. So these are some of the suggested topics. So, and then after you come up with your topic, then you need to, what you need to submit at the end of this subject, you need to submit a project proposal and doing the project presentation. Okay, I'm not sure how you can do the presentation. Okay, but later on, after we know the arrangement from the university, then we can confirm what are the days for the presentation. But remember that you need to do a project proposal, okay, and a PowerPoint for your presentation. And then for your project proposal, you can follow this format. Like, first of all, what is the project title? What is the problem definition and objectives? What is the methodology, responsibility for each team members? And what are the project significance and deliverables? So if you have any questions regarding to this project, please send me an email, okay? And finally, you need to submit your proposal and do a presentation during the presentation day, okay? Any submission will not be accepted. Remember to include your name and student ID in the proposal, and then using the student ID as the final name. And then you can assign one team member to submit the file to the Blackboard on the presentation day. And for your project presentation, the presentation time is 15 minutes, and then 5 minutes is Q&A session. We will stop your presentation sharply. The presentation time is 15 minutes only. So this is what you need to do for your project. And then another issue is that some students asking me why they got a low mark in their assignment. Okay, you still remember that you need to do an individual assignment. Remember that I have two. You got two in assignment. You have already completed one of the assignment already. Okay. Later, I will post the answer. I will post the answer on the Blackboard. Okay. I'll put the answer on the Blackboard. I'll put it here. Okay. Later on. Okay. And after finish this lesson, you need to do another assignment related to the decision tree. Okay, related to this decision tree. Okay, and then remember that the deadline for the submission of this decision tree assignment is on this 5 day. On this 5 day. Okay, 6th of March. Okay, so later on, I'll put the answer for the rule-based reasoning answer on the Blackboard. So if you have any question regarding to your marks, please take a look on the suggested solution. I'll post it on the Blackboard in the next week. Okay, please patient. Okay, so for the assignment, it is marked by my tutor. Okay, so I asked him that in order to mark your assignment, the marking is a little bit tight, because if it is very loose when marking your assignment, you will make mistake during examination. Therefore, during marking your assignment, it will be a little bit tight and the marks will not be quite high, because I want to let you know that what you need to pay attention during the examination. That's why the marking will be a little bit tight. And then if you have any question regarding to your marking, I will post the content of the tutor on the Blackboard later, so that if you have any question regarding to the marking of your assignment, please contact the tutor later if you have any further questions. Okay. So remember, the deadline for doing the decision tree assignment is on this 5 day. Okay, remember that night. Okay, go back to another topics, which is about the neural network. Okay, so neural network, I know everyone will know neural network. So why we would like to apply neural networks nowadays in doing the artificial intelligence? Okay, I'll tell you the reason later. Okay, now why we have the neural networks? Because we want to mimic the brain for the human. Okay, we want for the human brain, you see that, so we have some inputs, and then we have the brain of the human, and then we got some output. So that we want to mimic the situation that we have some inputs, and then we want to using the neural networks to simulate what we are thinking in the human. And then finally, you have some outputs. So this is the structure of the human brains. Okay. Actually, for the structure of the human brains, they are connected by the neurons. Okay. Okay, just similar to what the neural networks nowadays. So you see that for the neural networks, they are interconnected to each other. We have some neurons, so these are the neurons, and then they are connected to each others. Okay. Why we want to apply the neural network? Okay, so as mentioned before, we have some rule-based reasoning. We also have the decision tree, but this rule-based reasoning and decision tree do not have an ability, is the learning ability. So remember, when we're talking about artificial intelligence, learning is very important. So the rule-based reasoning and the decision tree do not have the ability to learn. That's why nowadays we would like to using the neural network, because for the neural network, the very important advantage is that a very important advantages is that it has ability to learn. It's very important, so that it can be generalized in many different applications. So these are strength and strength weakness. I'm not going to talk in details. Let's look on how it can be performed learning by using the neural network. Okay, so first of all, as mentioned before, for the neural network, we have some input. So we have the inputs with the neural networks, and finally we got the output. Okay, therefore, for the fundamental neural network, it is divided into 3 different layers: input layers, hidden layer, and the output layer. So these are the input. This is the input. This one is the output. And then this one is very important. It's just like our human brains. It is called hidden layers. Okay. For the hidden layers, for this case, we only have 1 layer. But actually, the number of hidden layers can be more than 1. That means we can have 2 hidden layers, 3 different hidden layers, 4 hidden layers, and so on. We can have many different hidden layers depending on how complicated of your problems. So remember that we got some input, and then we using our human brains and then make our decision, and then finally we've got some output. So that you will see that this information flow is in one direction. In one direction. This is called feed forward direction. Okay, this is called feed forward direction. So that we call this neural network a feed forward neuron network, because it is in one direction. Okay. And then secondly, for this neural network, you will see that we have different neural. Okay. For each neural, we call this one is a loop. Okay. We have the loop 1, loop 2, loop 3. So this 3 loop is used to form this input layer. Okay. And then finally, we have the output loop. This is output loop. And then for the hidden layer, we have the loop J and loop I. And these loops are connect each other. Remember, these loops are fully connected to each other. Okay? You will see that all of them will be fully connected. So that we call this neural network a fully connected feed-forward neuron network. Okay, so please remember all these terms: fully connected feed-forward neuron network. Okay, and then in order to connect this layer, this input layer to the hidden layer, we need to have some weighting. Weight. 1J. That means loop 1 is connected to loop J with some weight is equal to 1 W1J, and loop 1 is connected to loop I with some weighting. Okay, this weight is called W1I, W2I, W2J, W3J, W3I, and so on. And then we have WJK, WIK. So in this fully connected neural network, each network is, we have some weight with the weight for each networks. Okay, as mentioned before, we have some inputs. So there are 3 different inputs for the input layer. Okay, and then for this input, in the computer, it can only accept the value between 0 to 1. In the input layer, we only accept value between 0 to 1. Okay, it could be 0 0.1, 0 0.2, 0 0.112, 0 0.113, and so on. Okay, remember the value must be between 0 to 1 for the input layer. And similarly, for the output value, the value is also only equal to 0 to 1. Okay, in this case, we need to have some pre-processing in order to input the information to the neural network. Okay, and after we calculate the result, we need to have some processing to go back to come up with the solution. Okay, so as mentioned before, we need to have some numeric values between the range 0 to 1. So for example, if we want to have some input, for example, the input is red, green, blue, yellow. So these are the categorical data. Okay, this is divided into 4 different categories: red, green, blue, or yellow. Okay, so how can we convert this value into the range 0.1, 0 to 1? Okay, we can using 0 to represent red color. We can using 0.33 to represent green color. We can using 0.67 to represent blue color, and using 1 to represent yellow color. Or you can also using, for example, 0.5 to represent green color, and so on. So this is just your definition. Okay, this is a way to categorize these 4 different categories into the range between 0 to 1. Or you can using this way. Okay, for example, for the red color, we're using bracket 0, 0 to represent red color, bracket 0 and 1 to represent green color, bracket 1, 0 to represent blue color, and bracket 1, 1 to represent yellow color. So this is the method 2 to representing red, green, blue, and yellow color. This is method 1. So you can using either way to represent this data. Okay, but remember that the range must be between 0 and 1. Okay, how about the numerical data? Okay, for example, if the input for the input with 4 different values: 100, 200, 300, and 400. Okay, in order to convert this value to the intervals between 0 to 1, okay, we need to apply this equation. Okay, we apply this equation. Okay, so for example, so how to apply the equation? Okay, so for example, if you want to calculate Okay, so first of all, we start from the minimum value. So you see that the minimum value is 100. So that means it should be equal to 0. Okay, right? Because the value must be between the range 0 to 1. Okay, because 100 is the minimum value. So this one must be equal to 0. Okay, and 400 is the maximum value. So this one must be equal to 1. So how about 200 and 300? So in order to convert 200 into the values between 0 to 1, then we need to apply this equation to calculate what is the new value. So we can apply this equation, what is the new value? Okay, so what is the original value? So for example, if you want to calculate what is the new value for 200, the original value is 200. Okay, so this is 200, and then minus the minimum value. So 100 is the minimum value. So this is 100. And then over maximum value, 400 is the maximum value, minus 100 is the minimum value. Okay, so that we got 200 minus 100 over 400 minus 100. And then we get the result, 0.33. Therefore, we can using 0.33 to represent 200. 0 to represent 100. 1 to represent 400. Similarly, how about 300? It's very simple. So for this one, just using substitute 300 into this equation. 300. Okay. And then you get the answer, okay, which is equal to 0.66. Okay. 300 minus 100 divided by 400 minus 100. And then finally, you got the answer 0.66. So that we can using 0.66 to represent 300. Therefore, if we're talking about the numerical data, we need to convert them into the values between 0 to 1. Convert between 0 to 1. And then finally, we got that 0 is used to represent 100, 0.33 represent 200, 0.66 to represent 300, and 1 to represent 400. Okay. So this is the input. So these are the input. These are the input. How about the output? So how about the output? The output format is also similar. The output values must be between 0 to 1. Must be between 0 to 1. So how can we convert the output value into actual value? Then we need to using this equation. For example, if the original value is between 10 and 100, and after you apply the neural network, and we find that the output value is equal to 0.35, and then we want to calculate what is the actual output. What is the actual value? What is the actual value? Okay, you need to make use this equation. Okay, now in this equation, what is the actual value, or we call predicted value, is equal to new value times maximum value minus minimum value plus minimum value. So the equation is very simple. So what is the output value? The output value is 0.35. So this is 0.35, and then times bracket. What is the maximum value? So since the range is between 10 to 100, so maximum value is 100 times the minus the minimum value is 10 minus 10, and then plus the minimum value is 10. And then by using this equation, we can calculate that in the neural network, the output is 0.5. The actual value can be converted by using this equation. And finally, we'll calculate that the actual value is equal to 41.5. Okay. That means in the neural network, remember, input must be between 0 to 1. And also the output must be between 0 to 1. And then you need to using this equation and this equation to convert to the actual value. Okay. So actually we have an exercise, but we don't have enough time, so we are not going to talk about this. Okay. Okay. So as mentioned before, we have this fully connected feed-forward neural network. Okay, and then you will see that, okay, we have the input 1 for loop 1, 0.4 for loop 2, 0.7 for loop 3, and then for the loop 1, we have some weight 0.2, 0.1, and so on. Okay, so in order to calculate what is the input for the loop I, what is the input for the loop I, how to calculate the input for loop I, you see that for this loop I, it is correlated by this one, this one, this one. Okay, so in order to calculate what is the input for the loop, sorry, this is not loop I, this is loop J. Okay, what is the input for the loop J? Okay, how to do the calculation? You need to using this equation. Okay, that means for this equation, it is equal to input for the 1 is 1, and the weight is 0.2. That means 1 times 0.2 plus, okay, 0.4 times 0.3. 0.4 times 0.3 plus, okay, and then this one 0.7 with 0.7 times the weight, this one, the weight correct to loop J is this one, minus 0.1 minus 0.1. Okay, just like this one. Okay, so this one, that means this one. Okay, 1 times 0.2 plus 0.4 times 0.3 plus 0.7 times 0. Minus 0.1. Okay. Okay. You use this equation. Okay. And then finally, you calculate that, okay, the input for the loop J is equal to 0.25. So this is the input for the loop J. Okay. And then similarly, you calculate what is the input for the loop I. What is the input for the loop I? Okay. Similarly, 1 times 0.1 plus 0.4 times minus 0.1 plus 0.7 times 0.2. Okay. We're using the calculator. Okay. 0.1 plus minus 0.4 plus 1.4. Okay, which is equals to, this one is the input for the loop I is equal to 1.1. Okay, so the input for the loop J is 0.25, loop input for the loop I is 1.1. Okay, so how about calculating the output for the loop J and loop I? So this is the input for the hidden layer. This is a hidden input for the hidden layer for the loop I. So how can we calculate what is the output? What is the output for the loop J? So in order to calculate the output for the loop J, we need to using this equation, sigmoid function. Okay, we need to, in order to calculate the output for the hidden layer, we need to using this sigmoid function. I'm not going to talk about in detail all the sigmoid function, but the equation for the sigmoid function is equal to this one. So this is the equation for the sigmoid function. Okay. So as mentioned before, we got the input for the loop J is 0.25, and then we want to calculate what is the output. What is the output for the loop J? Okay. Then we need to using this sigmoid function, f bracket x. So this one loop J, we want to calculate output. The output is equal to function bracket 0. As the input is 0.25, we want to calculate f bracket 0.25. Okay, so we want to calculate what is f bracket 0.25. Very simple. You just need to substitute x is equal to 0.25 into this sigmoid function, and then you can calculate the result is equal to 0.562. So that for the output for the loop J, the value is equal to 0.562. This is 0.562. Okay. Similarly, we can also calculate the input for the loop I. So for the input for the loop I, okay, the value is equal to, sorry, 1 times 0.1 minus 0.4 times input. Okay, this is some mistake. So anyway, okay, so in this case, you find that the input, for example, here is 0.2. Okay, 0.2. This is the input. So this one input is 0.25. Okay, and then we apply the sigmoid function and then calculate the output. The output for this loop J is 0.562. So this is 0.562. Okay, and then we have the input for the loop I is equal to 0.2. So that this is for 0.2. And then we apply the sigmoid function for the loop I. So we apply the sigmoid function for the loop I, f bracket 0.2, and then finally we got the output for the loop I is equal to 0.55. Okay, and then similarly, what is the input for the loop K? What is the input for the loop K? So for the input for the loop K, you just using the output for the loop J 0.562 times the rate is 0.1. This is 0.562 times the rate is 0.1 plus 0.55 plus 0.5. Okay, and 0.331 is the input for the loop K. How about the output? How about this one? This one is just the, you need to apply the sigmoid function f bracket 0.331 apply the sigmoid function. Okay, and finally you just 0.331 you're using calculator to calculate this sigmoid function, and then finally you got the result. The final output is 0.5H2 by using the sigmoid function. Okay, so this is called fully connected feed-forward neural network. Okay, so this is the result, 0.582. So after we calculate this 0.582 result, then we need to go back here. Okay, need to apply this equation to convert to the actual value. Okay, remember this output is just between 0 to 1, and then we need to convert back into the actual value, okay, by using this equation, to convert into the original value. Okay, maybe we don't have too much time. Maybe we got 5 minutes break, and then please let me know if you have any question. Okay, 5 minutes. Please let me know if any question. Okay. No questions. Maybe it's too difficult. So if you have any questions later, you can also send me an email. Okay. So when we're talking about the neural network, okay, one major thing is that the neural network has the ability to learn something. Okay, actually, when we're doing the experiments, usually we will divide. For example, if we have a 100 data, okay, if for example we have 100 set of data, okay, we have 100 set of data. Okay, usually we will divide them into two independent sets. One is called training set, another one is called testing set. Okay, usually we will using 70% of the data. For example, you have 100 data. Usually we will using 70 data for the training. We're using 30 data for doing the testing. Okay, so what is the meanings for the training? Okay. That means we need to. So what is the meaning of training? So in this example, you see that we have some input, and also there are some weighting already assigned 0.2, 0.1, 0.3, and so on. Okay. So how can we obtain this value? How can we obtain this weight? Okay. How can we obtain this? So in order to determine what are the weights for this value, we need to do the training. So this is the meaning of training. That means we want to determine what are these values. Okay. During the training, the neural network will able to learn what is the best weighting for each neuron in order to calculate the best answer. So this is called training. Usually, we are using 70% of the data for training and 30% of the data to do the testing to see whether our answer is correct or not. Okay, so that we need to using the training set to do the neural network training. So when we're talking about training or learning, okay, there are two different types of learning algorithm. First of all, it's called supervised learning. Another one is called unsupervised learning. Okay, so the unsupervised learning is very difficult. That means we don't have answer. Okay, we have some input, but we don't know the answer. Okay, so it's very difficult. So most of the training is we are referring to is related to the supervised training. That means for a set of data, we know the input as well as the output. We know the input, we know the output. For example, we have some figures, we know that, okay, these are the cats, these are the dogs, and we, so that for when we're talking about the supervised training, for the data set, we know what are the input and we know what are the output. Okay, so in order to perform the supervised learning, okay, one of the major approach is using the backpropagation learning algorithm. So when you're talking about the supervised training method, one of the major approach is using the backpropagation learning algorithm. So in this backpropagation learning algorithm, we will calculate the error of the network, and we want to minimizing the error of the network. And then after minimizing the error of the network, we can do the modification in the weight values. Okay. So these are the weights. Okay. By applying the backpropagation learning algorithm approach, then we can modify this weighting. We can modify this weighting. Okay. So in the previous example, we calculate the value is 0. Okay, we have the input 1, 0 0.4, 0 0.7, and then we find out the output is 0, 0.582. But when we're doing the backpropagation train, we find that, oh, the target output is actually equals to 0.65. It's not 0.5 something, okay? It's the target value should be equal to 0.65. That means there are some error in the estimation. So by using this value, okay, we need to, okay, so the output is equal to 0.582, but the actual value is equal to 0.65. That means there's some error during the calculation. Therefore, we need to calculate what are the error, and then we need to apply this equation to calculate the error in the output layer. What is the output layer error? And then we need to apply this equation. So in this equation, T is the target output. OK means the calculated output. And then Fx means this is the first order derivative of the sigmoid function. Do you still remember the sigmoid function? So for the sigmoid function is this one. This is the sigmoid function. And then you need to calculate the first derivative of this sigmoid function. Okay. So after we calculate the first derivative of the sigmoid function, finally we find that the first derivative of the sigmoid function is equal to this one. Okay. So that we just need to substitute this one into here. Okay, so that finally we can calculate the error by using this equation. Okay, this equation actually is very simple. Okay, so what is the error of the output K, loop K? What is the error for the output loop K? So this is loop K. Okay, this is the this is loop K, and then we calculate the output is equal to 0.582, and the target value is 0.65. Okay, so that target value is equal to 0.65 minus our output value is equal to 0.582 times 0.582 times 1 minus 0.582. So very simple. Okay, we will find that, okay, the error for the output K is equal to 0.017. Okay. Similarly, how can we calculate the output error at the hidden layer? So in order to calculate the error for the hidden layer, we need to using this equation. Okay, just similar to the previous one. Okay, so the error is equal to the error of the output K. So if you have more than one output K, then you need to do the summation. But in this case, you just got only one output, so we are not required to do the summation. Okay, so this is the rate for the collecting the loop J and loop K, and this is the first derivative. This one is the first order derivative of the sigmoid function for the loop J. Okay, and then we calculate the first derivative. The first derivative for the loop J is equal to this one. Okay. Okay. Now, the error for the loop K. What's the error for the loop K? We just calculate. The error for the loop K is equal to 0.017. 0.017. And then what is the weight between loop J and loop K is equal to 0.1. So this is the original weight collecting loop J and loop K. And then how about this one? So this one is equal to OJ. So still remember what is the OJ? OJ means the output values of the loop J. what is the output values of the loop J? We just calculate is equal to 0.562. This is 0.562 times 1 minus 0.562. And then by using this equation, we find that the error for the loop J is equals to 0.00042. Okay. Similarly, we also need to calculate the error for the loop I by using the same equation. Okay. And finally, we find that the error for the loop I is 0.0021. Okay. So remember, okay, so remember, okay, so the error for the loop K, we just calculate is equals to 0.017, and then error for the loop J is equals to 0.00042, and then error for the loop I is equals to 0.0021. The error for the loop I is 0.0021. Okay. And after we calculate the error for the loop J, error for the loop I, error for the loop K, what you need to do for the next is to update this value, update this value. So how can we update the value? In order to update the value, we need to using this equation. Okay. So this is a weight connecting the loop J and loop K. Okay. This is the weight connecting loop J and loop K. So this one, 0.1, is the original weight connecting loop J and loop K. So this is 0.1. So what we want to do for the learning is that we want to calculate what is the new weight that can minimize the error. Okay, so what is the new weighting collecting loop J and loop K is that it is equals to 0.1 plus delta Wjk. So the delta Wjk is calculated by using this equation. Okay, so let's look on this equation. So this is the error. Now this one is the delta Wjk. So in order to calculate what is the updated weighting for the loop Jk, we need to using 0.1 plus delta Wjk. So for the delta Wjk, this is just equals to R times error K times Oj. So what is the error K? For the error K, we have just calculate error K is equal to 0.017. K is equals to, this one is equal to 0.017. Okay, how about what is Oj? Oj means the output of loop J. What is the output of the loop J? Output for the loop J. So this is the input. So output for the loop J is equals to 0.562. We have calculated before. So this is 0.562. So how about R? What is R? R means the learning rate parameters. Okay, the learning rate parameter will be between 0 and 1. Okay, you can set the learning rate equals to 0.1, 0.1, 0.2, 0.3, or 0.4. Usually, we're using the learning rate parameter R is equal to 0.5. Okay. If the learning rate is too small, that means it will convert to a correct solution very, very slowly. Very, very slowly. If the value is too large, it may not converge to a accurate value. So that it's very difficult to select a correct learning rate. Okay. Usually we're using R is equals to 0.5. Usually we're using R is equal to 0.5. Okay, so that you substitute 0.5 into this equation. Now, what is delta WJK? Delta WJK is equal to 0.5 times 0.017 times 0.562. And that is this one. And afterward, we find that delta WJK is equal to 0.0048. 0.0048. And then what is the updated value for WJK? Is equals to 0.1 plus 0.1 plus 0.0048. And the updated rate value for the WJK will be 0.1048. Okay. So originally WJK is equal to 0.1, but we find that after we do some training, we find that so this weight is not accurate. We need to update this value to equals to 0.11, so 0.1048. Okay, so this value is not accurate. You need to update this value 0.1 update to 0.1048 in order to get a better answer. Okay. Similarly, you also need to update WIK as well by using this equation. So first of all, we update WJK. Okay. We'll update WIK later on. Okay. First of all, we update WJK. After you update WJK, you can also need to update this one, and this one. Okay. Okay. After you update W1JK to 0.1048, similarly, we update W1J, W2J, and W3J. Okay. Now, originally the value is 0.2. Now it will become 0.2002. So this one should be equal to 0.2002. And how about this one? Originally 0.3, and we need to update to 0.300084. This one 0.300084, and this one originally is minus 0.1. Now we update is equal to 0.099853, and so on. So similarly, after you update the values for WJK, okay, you also need to update this value. Okay, WIK. So WIK, By using this equation, we got the answer, this one. After you got the WIK, you also need to update the values for the W1J, W2J, and W3J. And so afterwards, you update this one, and update this one. Okay. You may try by yourself. Okay. Later on. Okay. After you update all the weight, okay, you got this one. Okay. So originally you got the answer, but you find that by using the training set, you find that the answer is not accurate. Then you want to learn and update the weight. Okay. The update, the rating is called the learning. This is called learning. Okay, we update the weight by learning. Okay, and finally we got this updated weight. Okay, and based on this update weight, and then you find the answer again. And then if you find the answer is incorrect, and then you do the learning again and again. So that's why it's very, very time consuming in order to do the learning. Okay. So when you terminate the learning process, usually in order to terminate the learning process, how to terminate the learning process, we'll calculate the root mean square error. Okay, because we have many sets of data. Okay, remember that we have 70% of the training set data. Okay, 70% of training set data. Okay, you need to iterate again and again and again, and then calculate the root mean square error, and then finally for the answer with the minimum root mean square error, then this is the final answer for your weighting. Okay, so that we want to calculate, minimize this root mean square error. Okay, we want to minimize this error, and then finally the answer with the smallest root mean square error is your final answer. So that, okay, so that when we're talking about the learning in the artificial intelligence, you know that you need to have a very, very high computation power. Why we need such a high computational power? Because we need to repeat this learning with 70% of the training set, and then we calculate the minimum root mean square error. So you know, we need to repeat the calculation many, many, many times. That means that's why nowadays, in order to do the training, you need to have a very high computational power computers in order to do the AI. Okay. So that's it for the neural network. Okay. I know it would be quite difficult to you because in learning the neural network, you need to do many, many calculations. Okay. So that's the end for this lesson. And finally, just to remind you that I have posed the questions for the assignment on the blackboard. Okay, so you need to access to the blackboard. Okay, go to the content folder, assignment, and then we have the second assignment for the decision tree. So remember the submission deadline is on this Friday. Okay, so you can download the question a little bit slow for my network. Okay, and anyway, okay, so remember to complete the assignment by this Friday. Okay, so that's the end for this lesson. So any questions, you can leave me message. So if no question, so that's the end for this lesson. and see you and bye.